into this topic called a polynomial, and it's a finite sum and some could also mean difference, actually, like adding a negative. But it's a finite sum or difference of monomials. And monomials are these little, like 3x squared is a monomial. So an example that we could have something say like this. And this would be a polynomial. And here, let me put in a minus sign here, make it a little interesting. But you have 1, 2, 3, 4 monomials. This is also a monomial. It's called a constant monomial. In each one of these monomials, when they're in a polynomial, we also call them terms. So you have 4 terms or 4 monomials. Now, one of the things that we talk about with polynomials and monomials is this thing called degree. And you come up with a degree for a monomial, and then you look at all the monomials, and then the monomial with the highest degree will be the degree for the entire polynomial. So, for example, let's see. So to put it more formally, the degree of a monomial what it is exactly is the sum of exponents on the variables. It's only exponents on the variables. So here's some examples. Well, in this one, there's only one variable, the x squared. So the degree is equal to 2. Really nothing to add there. But if you have something like this, well, now we've got a couple exponents on variables. Again, if there's an exponent on the constant, we don't worry about that. That we ignore. But here your degree is 2 plus 3 or 5. If you have a variable that doesn't appear to have an exponent, it actually does. There's an invisible 1 on it. So the degree will be 1 plus 2 plus 7 or 10. So the last one to really kind of mention, the constant monomial, which is just a number by itself. That degree is 0. So if you have a term with no variables attached, it has a degree of 0. Questions about that? So now we look at the degree of a polynomial. So the degree of a polynomial is the same as the largest degree among its monomials. The degree of a polynomial is the same as the largest degree among monomials within it. So what that means, if you want to figure out the degree of a polynomial, you're going to figure out the degree of each of the monomials, and the largest degree that you find amongst those monomials, that will also be the degree of your polynomial. So for example, well, if we go through each of these terms, each of these monomials, this one has a degree of 2. This one has a degree of 1. And this one has a degree of 0. So amongst the monomial terms, the largest degree is 2. So the polynomial degree is going to be 2. So any questions about that? All right. So let me do another one. Let's say we have this. Let's throw a minus sign in here. Throw a minus sign in there. We want to make sure we keep those in there too. Now for this, you go monomial binomial or term by term. Here the degree will be 2 plus 1, or 3. For this one, the degree is 1 plus 1, or 2. And again, there's invisible ones on the y and the x. Here's the degree, well, it's just the invisible 1 on the x, so that's going to be 1. And here the degree, since this is a constant with no variables attached, it's going to be 0. So we have 3, 2, 1, and 0 for the degrees of our monomials in the polynomial. So the largest degree is 3. So the polynomial degree is 3. Questions about that? All right. So the next thing we get into is adding and subtracting polynomials. So adding and subtracting polynomials. And what this typically involves is basically we're just gathering like terms or combining. And sometimes there'll be distribution. Sometimes there'll be distribution of like a minus sign. But for the most part, that's what it's going to be. So let's take a look at an example. Let's see here. So we have this. Now we have parentheses around these polynomials, and we've got two. We got our first polynomial and we have our second polynomial. Now, the parentheses here, they're being used to say where one polynomial starts and ends, and where another one starts and ends. But that's about it. There's nothing being multiplied to the outside here. So we can just drop these parentheses. They're not necessary. Where they're going to be significant in this kind of situation is if we have something multiplied to the outside. And then we'll have to use distribution, or if there's a minus sign on the outside, we'll have to use distribution to get rid of the parentheses. So what we're going to do now, we're going to combine like terms. So we have a type x squared and a type x squared. There's 2x squareds. There's 3x squareds. So that's going to become 5x squareds. Then we have a 3x and a 2x. So there's 3x's plus 2x's. It gives us 5x's. Then we have 4 plus 5 is 9. And that's it. We're just combining like terms. Any questions about that? Well, let's take a look at another one. Now, they don't always have parentheses. Some of them won't. Well, again, in this case, we're just going to gather like terms. So you have a type y squared, and that's just going to stand on its own. Now you have a type y, there's negative 18y's and then 2y. So it's like it's negative 18 degrees, increases by 2 degrees. You're up to negative 16 degrees outside. And then we have a type constant. And that's going to be our answer. So negative 18 plus 2. The minus signs, those get attached to the monomial. So this 18y is actually negative 18y. Add a positive 2, you get negative 16y. Questions about that? Now let's say we have something like this. Now we're going to be doing subtraction. So when you see subtraction expressed in this way, subtract this from that. It's this that actually shows up first, then the subtraction, excuse me, and then this right here. So this will become 4x squared minus 5x plus 10. Subtract, it's going to subtract the entire polynomial. So this is where we're going to use parentheses, and then they're going to be real meaningful. And then, well, the others were meaningful too, to tell you which polynomial was which, but this is where it's going to have some mathematical consequences. We're going to have to distribute that minus sign. Ooh, No good. Another pen here. So what happens when you distribute the minus sign? We're going to treat it like we're multiplying by -1. So -1 times 2x squared, or you can also think of it as the opposite operator, where it makes positives negative. It's going to make negatives positive. So this positive 2x squared becomes a negative 2x squared. This minus 3x plus 3x, and this plus 5 becomes a minus 5. And now we're going to combine like terms. 4x squared, take 2x squareds away, we're left with 2x squareds. We have a debt of 5x's minus 5x's, but we recover 3 of them. So we're only short 2x's. And then 10 subtract 5 is 5. Questions about that? So again, just to kind of summarize what we do with that minus sign. Distributing the minus sign is like distributing -1 or the opposite operator. Questions about that? So the last thing to mention in this section is finding the value of a polynomial. And so what this is, we're going to use this thing called substitution. And we've done some work with substitution before, but just to recall, we replace a variable with a number. Now, when we replace this variable, we're going to replace it everywhere in the polynomial. And then we just do the arithmetic to figure out the value of the polynomial at that value for the variable. So the value of the polynomial will change depending on what we let the variable be. Let's see. So let's say we have something like this. Well, suppose we've got this polynomial. Well, first, let's let x equal 3. So that means we're going to replace x everywhere with 3. So this x gets replaced with 3. Now remember, constant next to a variable means times. And one of the things that we often do is when we do a substitution, we put parentheses around the number that we're doing the substitution. I'm sorry, that was substituted in. So that means we, instead of having x squared, we have 3 squared, which is 9. 2 times 3, which is 6, plus 1. And then, well, we do our PEMDAS, left to right with subtraction and addition. 9 minus 3 is going to be 6. And 3 plus 1 is 4. Questions about that? Now, so the polynomial's value is 4 when x is 3. Now let's change it up a bit. Let's say x is -2. So now everywhere where there's an x, we're going to replace it with -2. So -2 squared, that's -2 times -2. Negative times negative is positive. Then we have a -2 or a -2 times a -2. That's again a positive 4. And we add 1. And again, PEMDAS says go left to right. So 4 plus 4 is 8. And then 8 plus 1 is 9. Questions about that? So that's really it for adding, subtracting, and finding the values of polynomials. Next, we go on to 4.5. And this is multiplying. And we're going to start out with monomials. And typically what we're going to do, we're going to use those rules of exponents. So we might see something like this. So we're going to multiply our constants. And then we have our x's. And then our y's. And then 3 times 4 is 12. X2, there's an invisible 1 there, so that's going to be x to the 2 plus 1 times y. And there's a 1 here and a 3. 1 plus 3. And that's going to be our answer. Now, this kind of multiplication we've seen before. And what we're going to do with monomials is we're going to put them to work a little bit. We're going to now mix them up with polynomials. And what's going to happen here is we're going to need to do some distribution. So let's say we have something like this. So here we have a 3-term polynomial, and out here we got a monomial. So what we're going to do, we're going to distribute this monomial like it was a number or a minus sign. To each of the terms of the polynomial. So if we do that, what we're going to get is this. We're going to do that. I'm going to change up the color scheme a little bit. So now we're going to multiply these together. So for this, we have 2 times 3 for the constants, and that's 6. For the x, we'll add up the exponents. It's going to be 2 plus 2. And then 2 times 2 is 4. And then we add up the exponents. And when you multiply something to 1, it doesn't change anything. You're going to get that. You have 6 x to the 4th minus 4 x cubed plus 2 x squared. And that's going to be your final answer. So any questions about that? So let me do another one, a little more complicated one. So again, we're going to distribute the outside monomial. And so what that's going to give us is 6 xy cubed times 2x squared, and then 6 xy cubed times 5xy and that's what we're going to have. So now we're going to multiply our constants. 6 times 2 is 12. And that's x1, x2, so that's 1 plus 2. But we also have a y variable, but okay, for this multiplication, there's just the y cubed. Now for this other one, though, 6 times 5 is 30. Excuse me. And then there's x to the 1, x to the 1, 1 plus 1. And then we have y cubed y1. So that's 3 plus 1. So now we get that y coming into play. Then we have 6 times 12 is 72. The x is by itself, but we do have y's. And so what we're going to get, 12 x cubed y cubed plus 30 x squared y to the 4th plus 72 x y to the 5. And these are all different types of terms. Type x cubed y cubed, type x squared y4, type x y5. So they're not going to combine, they're different types. And so that's going to be it. Questions about that? I'm sorry if I'm erasing too fast, please let me know. So the next thing you're going to look at are binomials. We're going to look at multiplying binomials. So binomial multiplication. And the thing with binomials is a binomial has two terms, or two monomials. So we're going to come up with a technique called FOIL. And the way FOIL works is, well, I'm going to show you the long way to do this, and then we'll come up with the FOIL shortcut. So let's say we have something like this. Let's go 5. Now, the way we do this is we distribute. We're going to treat this entire binomial as if it's one term and distribute it to each of the monomial terms of the second binomial. So this is the first binomial, this is the second. We're going to distribute this entire outer part to each of the terms on the inside. So this will give us 2x minus 3 times 4x plus 2x minus 3 times 5. Well, now what do we do? Now, this is actually a familiar situation that we're in. We're going to distribute the monomial to each term in the parentheses. Same thing here. We'll distribute this to each term in the parentheses. So this will distribute in like that. This one will distribute in like this. And so we'll get 4x times 2x minus 4x times 3 plus 5 times 2x minus 5 times 3. So 4x times 2x, it's going to be 8x squared minus 12x plus 10x minus 15. So now we got to gather like terms. Still not done. This will be 8x squared minus 12 plus 10 is minus 2x minus 15 and that's going to be our answer. Questions about that? Make this 5 a little clearer. So I'll admit that that's a little lengthy, but we're going to come up with a shortcut. So I'm going to write this problem off to the side. We're going to do it again using the shortcut. But first, let's try to figure out what the shortcut is. So let's say we're going to talk about something called FOIL. And we're going to sort of derive the shortcut. So this is going to seem pretty abstract at first. Got A's, B's, C's, and D's. So we're going to do the same thing as before. We'll take this first binomial and distribute it to each of the terms in the second. And I think in the textbook, they actually do it backwards. I think they take this and distribute it to each of the terms in the first. That's perfectly fine. Either way will work. So what we're going to get ax plus b times cx plus ax plus b times d. We distribute the cx, we distribute the d, get cx times ax, we'll get cx times b, then we'll get d times ax plus d times b. Now, I'll admit, this is going to be a little confusing. Like, okay, well, let's see what comes out of this. So we got the c times the a. I should say it's going to be abstract, maybe not totally too confusing, but bear with me on this. X times x is x squared. B times c times x plus a times d times x. I can switch the order on these if we want. A times d, d times a, multiplication, the order doesn't count. And then we have b times d. And what I'm going to do, I'm going to factor out an x, or reverse distribute. So we have acx squared. We're going to pretend that there was an x on the outside of this thing that got distributed. So we're just going to go backwards. And the reasoning is that if you took this x and you distribute it to each of these terms, you're going to get this back. So we're going to go backwards and factor out the x. And then, again, addition, order doesn't matter. So we can rewrite this as ax squared plus a times d plus b times c x plus bd. In fact, you know what? I don't have to actually, I'm going to back up a bit. I'm realizing something. We don't need to factor out that x. I apologize. I'm going to go back. We can just switch the order on these two terms. And again, the reason is addition, order doesn't matter. So here's the idea of FOIL. we've got this, and this is the problem we're going to foil in just a little bit. If we take a look at the original problem, to get this first term, we multiply the first coefficients, or the coefficients on the first terms of each polynomial. I have an f here for first. We have a times c. Or I'm sorry, ax times cx. So we're going to bring the x's with them also. Then, to get this term, we multiply the outer terms of the entire multiplication. So you have outer ax times d. Then, to get this term, we multiply the most inner terms of the entire multiplication. So b times cx. And then to get the last term, we multiply the last terms of both polynomials, b times d. And we're going to be adding these up. So this is the FOIL shortcut. To get this term, we multiply the first terms of the binomials. To get this term, we multiply by the outer terms of the entire multiplication. To get this term, we multiply by the inner terms of the multiplication. And to get this last term, we multiply by the last terms of the binomials. And that gives us b times d. And so first, outer, inner, last. And that's going to be our shortcut for FOIL. Questions about that? I'll summarize what these stand for. All right. So what we're going to do when we FOIL, we multiply the first terms. Let me do it this way. The binomials. So the first terms of each binomial. And then we'll add to that the product of the outer terms of the entire multiplication. And then we add to that the inner terms of the multiplication. And then we add to that the last terms, the product of the last terms that there of the binomials. Questions about that? So believe it or not, this is a shortcut, and we're going to go do that we're going to multiply those two binomials from before, and hopefully it'll save us some time. So this is what we did last time. We took this binomial, distributed it to each of these terms, and then we had to distribute each of these terms into the resulting products. So instead, what we're going to do now is this. We'll multiply together the first terms of the binomials. So 2x times 4x. And then we'll add to that the product of the outer terms of the multiplication or the product. So 2x times 5. And then the product or multiplication of the inner terms. And the -3, the negative will go along, times 4x. And then the product of the last terms. And so what this becomes is 8x squared plus 10x minus 12x minus 15. And then we gather like terms, we'll get 8x squared minus 2x minus 15. Questions about that? So hopefully that makes that a little faster. All right. Now let's see. Now let's say, so that's how we can handle binomials. Now, if you get something a little more complicated, you might way. So for example, let's bring in some just polynomials. I see that camera's back. There it is. Ooh. So for polynomials, again with this one, we might just be stuck with distribution. Now there's another method we'll talk about called the column method. But let's say we have something like this. Now for this one, FOIL only works when you have two binomials. So that means we can't FOIL this because this is a binomial, so we're halfway there. But this is a trinomial or a three-term polynomial. So we're going to have to distribute. So what we'll get x plus 2 times x squared So you're going to get something like this. So now we're distributing this to each of these three terms. And then we got to distribute this in turn. So this one, because it's a binomial and a trinomial, there's really, well, there is another way we could do this. We'll talk about that. But x squared times x is x cubed. We'll get, well, here, I'll go through all the steps. We'll get x squared times x squared times 2. Now this one, we've got this minus sign. So I'm going to keep that minus sign on the outside for now. This will be 2x times x plus 2x times 2. So this one's going to get distributed with a minus sign a second time. Plus 4 times x plus 4 times 2. So this will become x cubed plus 2x squared. We're going to deal with this minus sign here, but this will be 2x squared plus 4x plus 4x plus 8. So the last thing to do is distribute this minus sign. And again, when you distribute a minus sign, you treat it as, you treat it as if you're distributing a -1 or an opposite operator. So this will become a minus 2x squared. This is a minus 4x. And we get something like that. So now we're going to try to combine like terms. Now taking a look at this, we have a type x cubed. So that's not going anywhere. But then let's take a look at the type x squared. Plus 2x minus 2x. Well, these are going to be opposites. They're going to cancel. So that's going to be 0. And then minus 4x and a plus 4x, those are opposites also. That's going to be 0. So the only thing left is the 8. So I get x cubed plus 8. And that's going to be our final answer. Now, there's another way of doing this. It's going to be called the column method. So I'm going to go through that. I'll show you what this other method is. And, you decide if you prefer it. So we'll take our same polynomial here, our trinomial. We're going to set it up like this. And I'm going to do a little bit of editing here. This column is for the constant term. This is for the x term. This is for x squared terms. And this is for x cubed terms. And you could continue on x to the fourth, x to the fifth, on the way down. So this is how the column method works. What we're going to do is we'll take the first term here and multiply it like long multiplication to each of these terms. So we'll get x times 4. We'll put that in the x term, it's 4x. Then x times negative 2x, well, that's negative 2x squared. And that goes in the x squared column. And then x times x squared is x cubed. And we want to make sure the signs show up. So this is a negative 2x squared, okay. And this is a positive 4x. Another way you could remember this is just x distributed to x squared minus 2x plus 4. Questions about that? Ooh, you can see that's an x squared, x cubed. I apologize, that's x squared and that's x cubed. So let me give you about 10 seconds to write that down. So I'm going to erase it and go on to the next stage. All right. So now we're going to go to the next stage of this. That's just sort of phase 1. So taking a look at phase 2, I'm going to rewrite what we had before. This is a constant column, x column, the x squared, and we'll need an x cubed, but we probably won't need an x4. We could put one out here if we wanted to, if we're going to need it. And so what we had was 4x minus 2x squared, x cubed. Next, what we're going to do is distribute the 2. It'll go to the 4, go to the minus 2x, it'll go to the 2x squared. Now, when we do that, 2 times 4 is 8, so this goes in the constant, and it's a positive 8, so we'll put a plus. 2 times negative 2x is negative 4x. 2 times x squared is 2x squared. And then we're done. There's no other terms to multiply. So just like with long multiplication, what we're going to do is add things. And when we add, we'll get 8 plus this will become 0. This will add to 0. And this is just going to be x cubed. So we add column by column. And what we had here in this line was 2 times x squared minus 2x plus 4. And that's what gave us this here. And so we add it together, and we'll get x cubed plus 8. So that is the column method. Any questions about that? So I'm going to go a little bit over today. I just have one example I want to show you, just because it's kind of a long one, but I just want you to see it before we finish the lecture section today. It's the last example for section 4.5. And it's when we have a trinomial times a trinomial. And again, you could do this using the column method. I'm going to show you the distribution method, but you could use the column method as well. And the column method, I think, is faster. But the idea here, we're going to take this and distribute it to each of these terms. Yeah, 2x squared plus x plus 1 times x squared plus 2x squared plus x plus 1. Oh, it's going to be a minus, actually, because it's a minus 4x. Minus 4x plus 2x squared plus x plus 1 times 3. And so we'll distribute the x squared. We'll distribute the 4x. Distribute the 3. And so when we do that, get x squared times 2x squared plus x squared times x plus x squared times 1 minus, we'll keep these parentheses, ooh, getting cats mixed up. 2x squared, 4x times 2x squared plus 4x times x plus 4x times 1 plus 3 times 2x squared plus 3 times x plus 3 times 1. Whew, quite a bit. And so we'll get 2x to the 4th plus x cubed plus x squared minus, in parentheses, 8x cubed plus 4x squared plus 4x plus 6x squared plus 9x, oh, I'm sorry, plus 3x plus 3. And so finally, we got to distribute this minus sign. So we get 2x to the 4th plus x cubed plus x squared. What I'm going to do is I'm going to start kind of aligning things. Minus 8x cubed minus 4x squared minus 4x plus 6x squared plus 3x plus 3. And if I add these terms together, so we're just like that, we'll get 2x to the 4th. And the reason I wrote it in this way is now I can go x cubed minus 8x cubed minus 7x cubed. 1, negative 4, and 6. That's going to be 3. So you get 3x squared. Negative 4 and 3 is minus x, and then plus 3. And that's going to be our answer. Now, admit that's kind of tedious. I'm going to do, and this is hopefully go much faster. I'm going to show you the same thing using the column method. I'm just going to go through it kind of quickly. And then that's it for today. I'm hoping I didn't make an arithmetic mistake. That can happen. So you have 2x squared plus x plus 1 x squared minus 4x plus 3. So we're going to start with the x squared. So x squared times each of these. So x squared times 1 is x squared. X squared times x is, that's a positive x squared. So this will be x cubed. And then x squared, 2x squared is 2x to the 4th. So this is our constant, our x squared x cubed. And for this one, we need to bring in x to the fourth. So now we go with this one. Minus 4x times 1, minus 4x. Minus 4x times x, minus 4x squared, minus 4x times 2x squared. That's minus 8x cubed. And so now we go to the 3. 3 times 1 is 3. 3 times x is 3x. 3 times 2x squared is 6x squared. 3 times 2x squared is 6x. Oh, I already got that one. And that's it. We're done. So this was a positive 3. This was a positive 3x. And now we're going to add. And this is so much faster. So we have plus 3. Negative 4 plus 3x is just negative x. 1 plus negative 4 plus 6 is plus 3x squared. X cubed, negative 8. It's going to be negative 7x cubed. And then we have the 2x to the 4. And that is so much faster. And that's it. Questions about that? So that's it for the multiplication. Well, it's not quite done. We have section 4.6. We'll get to that on Wednesday. We'll talk about section 4.6. And that's a kind of a fast section. There's some special products. We'll get through we'll probably do 4.6, 4.7 on Wednesday. We might be able to get into 4.8. We'll see. What'll probably happen is we'll do 4.6, 4.7, an introduction to 4.8 on Wednesday, and then we'll do more examples for 4.8. But that's it. If you have any questions, let me know. Other than that, I'll see you in lab in about 3 minutes.